a lesson on polynomials. This is going to be our first lesson in the new unit, and even though it's going to be some new things, it's actually going to be stuff that we have talked about already this year. So the first thing we're going to start off with is, what is a polynomial? And by definition, a polynomial is an algebraic expression made up of variables, numbers, any combination of these. We talked about these things earlier in the year when we talked about adding and subtracting algebraic expressions. We talked a little bit about multiplying them. So what we're going to find is that we actually have specific names and ways that we classify these things. And we're going to look first at two different ways of classifying polynomials. The first way that we can classify polynomials is based on the number of terms. So if you will recall, terms are separated by plus or minus signs. So when I look at this first polynomial here, where we have 4xy, notice there's no plus or minus signs. That means that this is just a single term, and we call that a monomial. Mono is the prefix meaning one. And we also have other names for other polynomials if we have more than one term. So in the second one, 4xy plus 3, here we can see 4xy is one term, 3 is the second term. Therefore, this is a two-term polynomial, which is a binomial. In the 3 term, we have the x squared, the 3x, and the minus 4. So this is a trinomial. So monomial, binomial, trinomial, those are the first three types of polynomials that we will look at. They're the three most common that we come across. And once we get to 4, instead of having specific names for them, we really just refer to them as polynomials of 4 terms, or in the case of 5 terms, it's a polynomial of 5 terms, and 6, polynomial of 6 terms. So monomial, binomial, trinomial, those are the three specific names we need to know, and then anything that's 4 terms or more is going to be a polynomial. When we look at these examples here, we just want to see, can we determine what kind of polynomial it is based on how many terms there are. So if you want to take a second to pause this, you can go ahead and try examples 1, 2, 3, and 4 on your own, and I'll go over the answers with you in just a second. All right, so let's look at example 1. In example 1, if we look at how many terms there are, we have the 3x to the 4th, and we have minus 27. Since there's only 2 terms here, this is going to be a binomial. In number 2, I see 4 different variables. I see A, B, C, and D. However, there's no plus or minus signs. So that polynomial only technically has 1 term. That makes it a monomial. In number 3, if we look at how many different terms are, we have the 8k to the 5th, we have the negative 2k to the 4th, the positive 3k to the 3rd, the 2k squared, and the minus k. So in this case, if I count them up, I have 1, 2, 3, 4, 5 different terms. Remember, we don't have a specific name. We just call it a polynomial of 5 terms. And for our last one, we have 2x squared minus 5x plus 2. So if we count here, we have the 2x squared, which is 1 term, minus 5x is our second term, plus 2 is our third term. That means if this has only 3 terms, this is going to be a trinomial. So classifying polynomials based on the numbers of terms, that is our first way that we can classify a polynomial. The other way that we classify polynomials is based on what we call the degree. And it's important here, when we read the definition, the degree of a polynomial that contains only one variable is equal to the highest exponent on a variable within that polynomial. So when we look at these, we're looking at each of the terms, and then we're looking specifically at the exponent on each different term. And the largest exponent represents the degree of the entire polynomial. So when I look at number 5 here, 2y cubed plus 4y, I see an exponent of 3 on my first term. And on my second term, the 4y, even though it's not written there, we know that this is an exponent of 1. The largest exponent here is the 3, which means the degree of this entire expression is 3. So if I look at number 6, I can see I have 4 different terms. We have 4r squared, we have 4r cubed, we have negative 3r, and we have positive 5r to the 4th. The largest exponent term here is the 4, which means the degree of this entire polynomial is going to be 4. If we look at number 7, 3 different terms. We have 2g to the 3rd, we have negative 9g to the 7th, and we have positive 8. The largest exponent on a variable is the 7 in our middle term, which means the degree of this entire polynomial is 7. And on the last one, if we take a look, you might be saying, I don't see any exponents there, which is true, but we need to remember this first term, a, has an exponent of 1. My second term, 2, is a constant. It is not a variable. It's just a number, which means even if it did have an exponent, I would simplify that to just a number. The exponent that matters is the one that's on the a, which means the degree of this whole polynomial is going to be 1. All right, so now let's look at our classifications, because just like with the number of terms and identifying those, we found that there were special names. Here, when we look at the degrees, we're going to see that there are specific names for different degrees of polynomials. And remember, we said polynomials can be variables or numbers or a combination. So in the first polynomial here, we have just 7. That is degree 0 because there is no variable, which means this is just going to be called a constant. And we talked about that before. Constant is another name for just a regular number like 7. In the second example here, where we have a degree of 1, we have 3x plus 4, and even though it's not written there, the largest exponent on the variable there is a 1. You may recognize this from everything that we've done this year already with solving and graphing equations. This is a linear polynomial. So anything that has degree 1 is linear. When we see degree 2, this is something you'll talk about a lot more next year in Algebra 2. This is a quadratic polynomial. When we get to degree 3, the largest exponent there, y cubed minus 1, that is a cubic polynomial. If it's degree 4, like we have the 3j to the 4th minus 2j to the 3rd minus 5, that's degree 4, so that's a quartic polynomial. And degree 5 is a quintic polynomial. So those are our classifications based on degrees. One of the things that we should point out with degrees is that it does help us identify a standard form. Meaning when we talk about polynomials, we're going to be comparing our answers with one another. We want to make sure that we have a specific way to write our answers so that it's easy for us to check with one another. It also, moving forward in your other math classes, we're going to see that different degrees tell us different pieces of information about polynomials. So it's good to have a standard form. Standard form in this case means going from left to right, from the greatest exponent to the least. And sometimes we call this descending order, but more commonly we refer to it as standard form. So what we're going to do is we're going to look at number 9. We have 3a squared plus 2 minus 2a to the 5th. Remember, whenever we talk about the terms, we do include the signs in front of those things. So when I look at 3a squared plus 2 minus 2a to the 5th, standard form tells me the largest exponent here is the a to the 5th. But when I write that term, I must include the negative 2 as well. So when I rewrite this in standard form, negative 2a to the 5th, that comes first. Then I look for the next largest exponent. That would be the 2 on the 3a squared. So plus 3a squared would be my second term. And then the last term is just the constant here, plus 2. Anytime we have just a number in these polynomials, that's always going to be the last term. So plus 2 would go at the end. There is our rewritten polynomial in standard form, negative 2a to the 5th plus 3a squared plus 2. Go ahead, if you want to pause and try number 10 on your own, you can. Okay, so if we look at number 10, again, our largest exponent term here is going to be the 5r to the 4th. So that's going to go first in standard form. Then we have the next largest exponent is the 3. So we have plus 4r to the third. Then our next largest exponent is the 4r squared. There's no sign in front of that. Remember, we interpret that as a positive. So plus 4r squared. And finally, our last term here, based on the exponent, is the minus 3r, because that's an exponent of 1. So we have 5r to the fourth plus 4r cubed plus 4r squared minus 3r. All right, so that takes care of classifying polynomials based on the number of terms and the degrees and finding the standard form. We got 3 final examples here for you to determine what are the classifications based on the degree and the number of terms. Again, if you want to pause, you can. I'm going to keep going. So if we look at number 11, 3x to the fourth minus 27, first thing we're going to look at is the degree. So when I look at the degree in this case, that's the exponent here. That would be 4. So that tells me that this is a quartic polynomial of some sort because it's degree 4. And then the number of terms, if I look, there are 2 terms here, the 3x to the fourth and the negative 27. That makes this a binomial. So put together, we would refer to this as a quartic binomial. That would be its full name. If we look at number 12, again, the degree, if I look, there's no variable here. So this actually has degree 0, which means in this case, this is a constant because there is no degree. But then when I look at the number of terms, there's a single term. That makes it a monomial. So negative 7 is a constant monomial. And if we look at the final example, we can see here that the degree, the largest exponent, is the 5, which makes this a quintic. And if I look at how many terms there are, I see 1, 2, 3, 4 terms. So that makes this a quintic polynomial of 4 terms. I'm going to write out of 4 terms. Moving forward, you might see just polynomial. That would be okay as well. But quintic polynomial of 4 terms will be our final answer. All right, let's move on to the second part of this week's lesson. The second part is dealing with adding and subtracting polynomials. And you're going to see here a slide that we saw way back at the beginning of the year when we talked about combining like terms. Because when we get down to it, adding and subtracting polynomials is essentially just combining like terms. So I have here the same slide that you saw when we talked about like terms earlier. We have the definition. Like terms means terms that have exactly the same variable and exponents. And when we say combine, we really mean we're going to add or subtract. So I have there the 2 charts comparing some examples of like terms, some examples of unlike terms. Let's go ahead and remind ourselves of how is it that we combine like terms. So we can only combine like terms, meaning we can only combine things that are the same variable and have the same exponents. And when we do that, all we're going to do is combine, meaning add or subtract the coefficients. So we're going to combine the coefficients. So we're going to add or subtract whatever the number is in front of the variables. And then we keep the variable and we keep the exponents the same. So if I look at number 1, 3k plus 9k, my 2 terms are the 3k and the positive 9k. I add the 3 and the 9 to get 12, and I keep my variable as k. There's my final answer. 3k plus 9k is 12k. If I look at number 2, I want to write in standard form. So that means, first of all, I want to start with the largest exponent. So we're going to first identify the terms with the largest exponent. We're going to combine those, and then we will look at the smaller exponent. So if I look at number 2, I have negative 6b to the fourth plus 4b to the third plus 2b to the fourth minus 5b to the third. So the first thing I'm going to do is box the negative 6b to the fourth and the positive 2b to the fourth. because those are the largest exponent terms. I'm going to combine those. So negative 6 plus 2 gives us negative 4b to the fourth. Then I'm going to do the same thing with the smaller exponent terms. Positive 4b to the third and negative 5b to the third, which means when I combine those, positive 4, negative 5, that's negative 1. So negative 1b to the third, or if you just want to write minus b to the third, that works as well. I can't combine these two things because b to the fourth and b to the third are not like terms. So we're going to leave that as our final answer. So you might be saying, well, how is adding or subtracting polynomials any different? Basically, what we're going to have to do is use some other skills that we talked about earlier in the year. Go ahead, try example 3 and example 4 on your own first, and then we'll get into those. All right, so in example 3, you may have looked at that and said, wait a second, I have j to the fourth, I have j to the third, a j squared, a j, and just a constant. None of those are like terms. That one you didn't have to rearrange or combine anything at all. That was already in standard form. If you look at number 4, again, we start with the largest exponent terms, the negative 2x cubed, negative 4x cubed. That gives me negative 6x cubed. Then I go to the 10x squared and the negative 6x squared. When I combine those, I get a positive 4x squared. And finally, for my last term, I'm going to have the 4x and the negative 8x. That's going to give me minus 4x. So there's my simplified answer. Negative 6x cubed plus 4x squared minus 4x. As I was saying, adding and subtracting polynomials, basically the same idea, but the biggest difference here is that we need to use the order of operations to help us simplify a little bit here, because you may recall, anytime we have parentheses or grouping symbols, we need to get rid of those first before we do anything else. The way that we do that is we distribute. And you say, what do we distribute? We distribute the number in front of the parentheses. In the case of number 5, that means we have a 1 in front of k squared plus 4k minus 3, and we have positive 1 in front of 6k minus 1. So we're going to distribute 1 through the first set of parentheses. We're going to distribute 1 through the second set of parentheses. And the thing here is when we distribute 1, nothing actually changes. We're basically just rewriting these expressions, but without the grouping symbols. So what that allows me to do is now just combine the like terms. If I look, I have k squared as my largest term. So that's going to go first. Then I'm going to combine the positive 4k and the positive 3k, positive 6k to get positive 10k. And lastly, we combine the negative 3 and the negative 1. That gives us negative 4. So k squared plus 10k minus 4 would be our final answer here when we add those polynomials together. When I look at number 6, in this case, similar idea, except you notice now that we are subtracting the 6k minus 1.